From the point of view of contemporary science, the theory of relativity is a valid and indisputable image of the real world. Scientists are able to present countless proofs of validity of this famous theory and present lots of new evidence every year. How then can anyone dare to question the theory of relativity? And what fool would dare to ignore the scientific evidence? However, the history of human progress tells us many stories about how all evidence always has only provisional validity. Even Aristotle once had plenty of evidence for his claims that the Earth is the center of the universe, and the planets as orbiting in perfect circles. Yet his follower, Galileo, spent the end of his life in prison because he dared to ignore the evidence that Earth is the center of the universe. At the same time, Kepler decided to resist textbooks and said not only that everything was circling around the sun, but also questioned the perfection of circles. And since the time of Kepler, the planets orbit around the sun on elliptical trajectories. Kepler's scenario of elliptical trajectories and the heliocentric model present the idea of an immovable central sun we believe today. And even our science can show a lot of evidence about such heliocentrism. All this despite the fact that already in 1687, Newton reasoned that the sun is not the immovable center of the solar system, but it counteracts to planetary movements. However, this information has not yet arrived in most school textbooks. Any evidence of science at any given time must therefore be taken with a grain of salt, which applies even for the present and the theory of relativity. And what is the problem with this most famous scientific theory? Although most people believe that Einstein's theory is about the relativity of time, it is in fact the relativity of motion. If we have two boats on a calm lake, and one of them is floating in a straightforward motion, while the other is anchored, then according to the special theory of relativity, our traditional thinking is misguided, and there is no point in discussing which of the ships is moving and which is calm. Both supposedly move equally, relative to one another. The general theory of relativity then goes even further, even referring to the mechanics of our solar system as relative, and the age-old dispute over the geocentric or heliocentric scenario of the universe is meaningless. Both descriptions of the world are again equivalent. Whether the Earth circles around the Sun or the Sun around the Earth, observers on both objects will have their subjective or relative truth, claiming I am in the still center and the other circles around me. The relativity of motion is aged, a physical, philosophical phenomenon that has been trying to challenge Newton and his famous bucket experiment. Newton did not believe in the relativity of motion on the grounds that when we hang a bucket of water on a twisted rope and the bucket starts spinning, the water flows by means of centrifugal force into a bowl shape, which Newton interprets as the bucket's objective motion to the universe. However, Einstein and relativists always contradicted the argument that when the bucket is stationary and the universe rotates, the experiment will have the same result, and therefore it is impossible to determine who is moving objectively and who only seemingly. It is this claim, the relativity of all motion, that has been the primary basis of the theory of relativity for over 100 years. And where is the weakness in Einstein's argument? Relativistic physics only works theoretically, and only if there are just two entities in the universe. As soon as there are more objects in the sky or more boats above the surface of the water, relativism evaporates like steam above a pot. The scenario that my boat is moving, while the 10 surrounding boats are anchored, is much more likely in the real nautical world than the alternative that my boat is still anchored, and all 10 surrounding ships are floating completely synchronously around me. By the way, the truth will also reveal the inertial forces during any acceleration of the ship. They are always objective evidence of movement. And if we hang two buckets of water on two twisted ropes, we get unmistakable evidence that the buckets move objectively to the universe, not the universe to stationary buckets. The universe can hardly rotate with different frequencies in different directions at the same time. Similarly, if a space probe during its stay on Mars measured that the Martian year lasts 687 days instead of 365 days, then it is quite clear that the planets orbit the Sun and not the opposite. The Sun cannot circle around planets at different frequencies at the same time. Therefore, the principle of relativity does not work in the real world and the real universe, which is a rather serious problem for the theory of relativity. If the basis of this theory is wrong, its conclusions, of course, are not correct as well, even though in some partial aspects the theory of relativity has uncovered true knowledge. The truth remains that time is not a universal phenomenon. Time runs slower for moving objects. Time dilatation truly exists. The equation E equals mc squared is also true. However, it is not true that there is a contraction of lengths. The distance from the Earth to the Moon is the same for everyone, whether traveling with the Apollo mission or the Starship Enterprise from the Star Trek series. Similarly, the meter standard will remain exactly 1 meter long, regardless of the speed at which it's fired. In a particle accelerator, the proton moves objectively toward the stationary accelerator, not the accelerator toward the stationary proton. Spacetime exists, but it is not curved. Even a supermassive object in our universe does not affect the course of time, and black holes are therefore just a figment of fantasy. They do not exist in the real universe, just as there are no supposedly discovered gravitational waves. Even today, there are many other things to correct in school textbooks, all because of one big mistake, the essence of which was Einstein's philosophical worldview. It may seem that relativism prevails over common sense. The real world around us and the history of physics are, however, evidence that realism and truth ultimately always prevail over any dogmatism and all pseudoscience. The world is far more simple than you've been told. There is no curved space-time in it, no black holes, no dark matter. To understand gravity or time dilatation, you do not have to solve complex differential equations. You just need a ruler and a compass. It's a piece of cake. You don't believe it? Time theory will open your eyes.